you like to know. It's called chemistry.
This is parkour.
Parkour!
Hi Maddie, hi Ella, hi the rest of Pinkerton AP Chemistry. My name is Sara Carrier. I'm a physician assistant in family practice. I've been practicing for about 16 years now. Anyways, how does chemistry have to do with medicine? It has a lot to do with our body and what it's made up of. The FDA even has what they call 12 essential minerals that come straight from the periodic table that are essential to our well-being.
Oxygen and hydrogen are necessary to function because they are what makes up water, and our body cannot live without water. Carbon has 4 bonding sites that allow for the building of long, complex chains of molecules. Carbon bonds can be formed and broken with a modest amount of energy, allowing for the dynamic organic chemistry that goes on in our cells. Nitrogen is found in many organic molecules, including the amino acids that make up proteins and the nucleic acids that make up DNA.
We all know that calcium is needed for our bone structure and for our teeth, but it also helps to regulate protein and helps with muscle contractions. If our bodies don't have enough calcium intake, our body will start to take it from our bones, which is what leads to osteoporosis.
Phosphorus is found in bones, but also in the molecule ATP, which provides energy in cells for driving chemical reactions. Potassium is an important electrolyte. It helps regulate the heartbeat and is vital for electrical signaling in nerves. Sulfur is found in 2 amino acids that are important for giving proteins their shape.
Things like sodium we need because that helps with electrical signals for our nerves. It also helps with water balance in our body.
Chlorine is an electrolyte that is important for maintaining a normal balance of fluids. Magnesium plays an important role in the structure of the skeleton and muscles. It also is necessary in more than 300 essential metabolic reactions.
Iron is also found in hemoglobin, and hemoglobin is what carries oxygen to the rest of our body, so that's pretty important.
Fluorine is found in teeth and bones.
Zinc is necessary in regulating genes. Several proteins contain structures called zinc fingers, which help to regulate genes in the body. Zinc deficiency has been known to lead to dwarfism in developing countries. Copper is important as an electron donor in many biological reactions. Without enough copper, iron wouldn't work properly in the body. Iodine is required for the production of thyroid hormones, which regulate metabolic rate and other cellular functions. Selenium is essential for certain enzymes, including several antioxidants.
Chromium helps regulate sugar levels by interacting with insulin. Manganese is essential for certain enzymes, in particular those that protect mitochondria. Cobalt is contained in vitamin B12, which is important in protein formation and DNA regulation.
So how does chemistry have to do with medications? Well, medications are all basically these chemical reactions that happen in the body. So knowing these chemical reactions helps us to know what to prescribe for different patients. Things such as, potassium. If they're low in potassium, it can affect their heart rate and their rhythm. So then you need to prescribe a potassium supplement. There's other different medications that you would prescribe, say, for blood pressure, a calcium channel blocker. Well, that's right there in the chemistry.
Many common medical tests include chemical techniques and instrumentation. For example, high cholesterol and diabetes require laboratory tests in which chemistry is necessary as a deciding factor of what a person has and what can be prescribed to help. Another example is testing one's blood glucose level. A portable device is used that runs a chemical test on the blood sample and tells you how much glucose is present. This allows people with diabetes to regulate their health and decide what nutrients they may need.
Coming up on Dance Moms.
My major was biology, which Mr. Brita says isn't a science.